Okay, welcome. This is Lightning Review 5, a quick review of context-free grammars. This is a companion video to Lecture 5. So context-free grammars are a very flexible, expressive way to represent languages. So whereas a DFA or an NFA or a regular expression, all of those can be used to represent a regular language, a context-free grammar can be used to represent any context-free languages. That is a language from a larger class. So let's see how to do that. So here's an example of a context-free grammar. Perhaps we have our start symbol S and a production rule that tells us we can start with S and replace S with 0, S1. Another production rule that tells us we can take an S and turn it into a different variable B. And finally, a rule that tells us we can take the variable B and turn it into the terminal, the pound sign. So if I wanted to derive some strings using this grammar, well, I'd always start with my start variable, and then I follow any sequence of rules until I end up with only terminals left. So from S, I could take either production rule 1 or 2. Suppose I take production rule 1, and I take it again. You can see here how I've left the 0 and 1 from the first use of the first rule, and I've just replaced the S with 0, S1. So now I have a total of 2 zeros and 2 ones. Now maybe I choose to use rule 2 to turn my S into a B. And finally, I use rule 3. And at this point, I have the string 00 pound 11. And that corresponds, that's a string which is all terminals. Once I get to all terminals, I'm done. Terminals don't appear on the left. There are no rules for transforming terminals. They're just ends. Likewise, there's no reason why I had to use rule number 1 twice. Could have just used it once. And that would have given me a different string, also derived from the start symbol in this grammar. I could have gone straight to rule 2. There are, in fact, an infinite number of strings that I can generate using this grammar, depending on the number of times I use rule 1. The only thing that's similar between them, they all have to ground out in a string containing only terminal symbols. It's also occasionally helpful to visualize derivations as parse trees. That is, I start with the start symbol, and instead of just writing an arrow to the thing I get in order, I'll actually draw a little tree that demonstrates each use of my rules. So if I wanted to write this derivation as a tree, I could say, okay, I'll use rule 1, and I'll turn my S into 0, S1. And I'll use the first rule again, 0, S1. Then I'll use the second rule to turn S into a B and B into a pound sign. I can then read my final string off of this tree going left to right, 00 pound 11. I can also very clearly see where I've applied each rule. So every variable will have a few new variables or terminals descending from it, and that'll tell me which rule I used. I used rule 1 twice, then rule 2, then rule 3. I could also do it for this one very quickly. That would just yield this particular parse tree. So that's our example of using a context-free grammar. Let me write down the formal definition for you. So the formal definition says that a context-free grammar is a 4-tuple, and that 4-tuple is V, sigma, R, S. And in particular, these things are specified as follows. So V is a finite set of variables. So in our first example, V is S and B. Sigma is a finite set of terminals. In our first example, the set of terminals is 0, 1, and the pound sign. R is a finite set of rules, each of which maps exactly one variable. So those are the things you see on the left-hand side. To a string of variables and or terminals. So each rule will tell me, hey, give me a variable like B. I'll tell you one legal thing you can turn it into. And then finally, S, we need to know where to start. So S is our start variable. I should note that it's perfectly legal to write down a CFG in brief form. Which I have already done. So if you're feeling lazy and you don't want to write down every single rule, every single element of this for tuple, well, then you can do what I did above. You can just write down the rules. For example, with this CFG, S, the production rule that goes to A has a production rule that goes to 0, A, 0. Rather than writing down the third production rule, I'm going to save myself some space, write a slash. This means that there's a second production rule for A. A can be replaced with, excuse me, not 1, 0, 0, 1, 0. I meant to write 1A1. And even a third production rule for A, epsilon. So here I've written down 4 production rules. And if you want, I claim you can read all of the information that's in the CFG definition right off of this sequence of rules. So in particular, the top left variable is always my start variable. The list of all the variables on the left, that list is my V, my set of variables. My set of rules and my set of terminals, I can read off immediately. So here I've written down 4 rules, S to A to 0A0, A to 1A1, A to the empty string. My set of terminals, that's all the symbols on the right-hand side that don't appear on the left-hand side. So all the terminals that appear that are not variables. And of course, I can then, I've got this grammar, I can start deriving things. This particular one will give you the language of all even length palindromes. Maybe you can see why that is, but I will leave it as an exercise. Thank you for watching, and I will see you in class.